Cool. Okay. Well, welcome back, everyone. So for today, there's mainly two things that I want to try to accomplish. One is to finish up the 10 kind of questions that we started with Torfs and Bauer 2 weeks ago. And then if that goes well and everyone's feeling comfortable with all of that stuff, then maybe we can roll into this lecture document that I put together about data science in R. And there's a PDF of that on Canvas that should be published for everyone to see now. Okay, so in that other video, I did record the lecture when we started this on week 2. We went through some of the very basic data structures that you might see in R. So we talked about scalars being 0-dimensional, just a single number or a single bit of information. We talked about vectors being a column or a row of data, so it's 1-dimensional. We talked about matrices being 2-dimensional. With information. And typically in a matrix, all of the information is consistent. It's all measurements from the same object, for example. If you have columns that represent different values, you might want to create a data frame, and we talked about a data frame. And then you may create a list if you've got different vectors of various lengths that you want to store together. Okay, so we went through that. And then some of the basic coding about how to create objects and name those objects and see how they load into the environment. We talked a little bit about creating histograms. And so today we'll pick up on is I'm just going to annotate here in RStudio, and I'm just going to call this question 8. And this will be how to handle missing data. And so if you remember, we can create an object called incomplete. And we'll use that left arrow. And then we're just going to concatenate the numbers 1, 2, 3, 4, 5, 6. We'll say 7 is missing, and we can put capital NA. Then we grab 8, 9, 10. Okay. And these are sequential numbers, but the point is when you want to put in a placeholder, but the number or the value is not available, capital NA is a good way of denoting that. Okay. And so I'll just hit run right here to push that down into the console down here. And then notice that we now have this object called incomplete. And we can click on that. Actually, it's just a vector, so it's not going to come up as if it were an object. Okay, so it's just incomplete. We could type into here this item called incomplete and hit run, and it'll come up in the console down here. And notice that NA, and that's important. And the main point that I want to make here is if you wanted to do something like maybe compute the maximum value of that vector of data, there's a function in R called max. And then we can do max of incomplete, if I could spell it correctly. And notice the nice thing about RStudio is it identifies that object that we created called incomplete, and I can click on that and it auto-fills. Okay, so the point of this is I want you to recognize that NAs can, although they're great for placeholders, can sometimes cause issues. So if I run that, notice that it runs the function max, but it returns NA. And that's because it's looking for a vector of data, but it's detecting this text that's in there. And what we can do is we can just add one more argument to this function max. We can say incomplete. And then we can do na.rm, which stands for not available remove. So we want it to exclude NAs from the calculations. And this is a Boolean, you may hear it called, or a yes or no. It's either a true or a false. And in R, it's looking for all capital letters on true, all capital letters on false. Notice how when I type those in there, it goes from black text to blue text, meaning that it's recognizing it. But one of the shorthands that you'll learn is that you can also just do a capital T, which would be the same as true. And the default, by the way, is false. It will not remove them. So it included that NA and it didn't give us a maximum value. So we're going to change that default from na.rm equals false to na.rm equals true. Okay. And remember, if you want to know all of the defaults for that, you can just do question mark and then type in max. If we run that, Notice it comes up down here. It's from the base package. It can give us the extreme values, the minimums, the maximums. We can go down to uses, and it gives examples of them. And so notice that it has this na.rm equals false. That's the default. And what we did was we just changed that default to true. Okay, so I'm going to go back up here and run this. And notice it now gives us the maximum value. What it did was exclude the text that's coded as NA, and it allowed for that function to work. Okay, and so we'll see this again, this na.rm in various functions that we use from the packages that we download from the CRAN. There's almost always missing data. For those of you that are ecologists, you recognize that sometimes you just miss data. Field equipment breaks or you miss an observation. You just never know. And statisticians have called my data messy data because they're not perfectly balanced and there's missing observations. And I've always been insulted by that because we put a lot of time into planning data collection. It's not missing, it's just real world data. And so, just remember that na.rm because we'll see that again, okay? So that was number 8. Anyone have any questions or thoughts about that? There's other functions that you can explore within this base package. I've just been calling out a few as we go. Okay, I'm just going to open the chat here to make sure that I don't miss any questions from anyone. Okay, it looks like the chat's empty. Okay, well, let's just go on to number 9 then. And of course, if you have a question, we can always go back. And the last, the thing on question 9 on here is how to deal with categories, okay? So when we created this object called incomplete, it assumed that we were wanting numbers, that those were numeric values. And we put in the number 1 and the number 2 and the number 3. But if we created that, if we created something called incomplete 2, and we typed in C and we put quotations around those, and we won't type the whole thing out. We'll just do 1, 2, 3. And you run that. Notice now, if you look over in your environment, it gives incomplete. The first one was numeric, 1 through 10, and it gave the values. There's 10 items stored in there. One of those was an NA. Incomplete 2, it now has CHR instead of NUM. And that represents the fact that those are stored as characters, as text, not interpreted as numerical as if we just put a number in there, okay? And so this will be important if you've got categorical data, but you've scored those categories on a scale that is numeric. And so one of the things to just kind of pay attention to is what are the actual, what's the class of the data that you've entered? Is R interpreting it the same way that you're interpreting it, okay? And so all of this information that's given up here in the environment is really helpful information, okay? But we could do, I just want to give a couple of quick examples of what happens if you use more complex characters, okay? So we could create an object called fishes, for example. Those are my personal favorite organisms, so a lot of the examples are fishes. And we'll just use common names for now. Most of the time, if you'll recall in that Bohr et al. Paper, genus and species, and maybe even the describer is what you want to do when you're building a database. But since not everyone here is really interested in the details of fishes, we can just do things like, we'll say alligator gar. Okay, that's a fish I was out researching yesterday with some of the grad students in the class. And then we can do maybe blue sucker. All right, that's another species that occurs in the state of Texas that we spend some time thinking about. And so when we create this thing called fishes, notice that I put quotations around those. And when we run that, we now have this object called fishes, characters. There's 2 objects stored in there, alligator gar and blue sucker. What I want you to notice is what happens if we don't put quotations around that. Okay, so I'm gonna highlight that. So all I did was I triple clicked. So you can click once, you can click twice, or you can click 3 times, and it highlights the whole line of code. And that was just with the left click. Then you can right click on it, and you can copy, and you can paste. And so this is a neat feature of the script editor in RStudio, is you can kind of treat it like you might a more traditional Word document where you're doing things like copy and paste. You can also do Control F, and you can do find and replace, just like you would in any regular document. And then you can find certain characters or certain words or values, and you can replace them with another. Okay. So we'll kind of explore some of those features as we move through R, but or move through this course. But there's a lot of similarities between this script editor up here and what you might be used to using in other documents. Okay. So what I wanted to show you is just what happens if you want to do that, but you forget to put the quotations around it. Okay. So we want to create this thing called fishes, and we'll call it 2. And we want to have alligator gar and blue sucker. And so if we run that, notice that we get this error, unexpected symbol in fishes 2, C alligator gar. And what it's not sure about doing here is whether this is an object that currently exists, or if this is something that we're creating. Okay, so putting the quotations around that is really important. Okay. And this is related to the fact that spaces and the use of spaces in R is like always problematic. So you might want to try to get away from it. So you could try doing what we refer to as camel caps. So every word, you push the words together to get rid of the spaces, and then for every new word, you capitalize the first letter. And we can try this. So we've excluded spaces. But now we get a very different error. It says object alligator gar not found. So now it's more explicitly telling us it's looking for something that's already been created called alligator gar, but it doesn't exist, so it couldn't find it. And so this is, again, confusion between, is this a new item that you're creating, or is this something that should already exist? And the quotations around those character strings are important for denoting that. Okay. Everyone doing all right? And so we'll spend a little bit more time with this later on. The main point I wanted to make was the difference between numeric and character strings, and then the fact that if you are creating characters, you've got to have the quotations. Okay. All right. Well, we can wrap this up then with question 10. And this one is concerning the use of time. How to code dates and time. And in that video that I recorded, I make the point that formatting dates or time can be a bit of a headache because we tend to store it differently. In the United States, we think about time differently than other countries or even the rest of the world, where it's usually year, month, day. So from the most significant to the least significant character. But we typically show month, day, and year. And when you're doing all of that with just 2 digits, it becomes even more confusing, right? So there's some standard formats to use for time that if you are doing research that includes timestamps that you just kind of have to learn and begin to use. And so one of those is this function st. Here, I'll write it out. We can do question mark str, and we're going to do p time. Okay, so we can click on this with the question mark in front of it. We run it. It comes up in the help down here. Okay, date time conversion function to and from character strings. Okay, in this strings to this stands for string points, the P, to time. Okay, so we're going to take individual points and we're going to put those on a timeline, basically. Okay, so what we can do, so I'll just give you an example of how to use this. Okay, and we're going to come back to this later. So we could start by creating something called class underscore time. And we can use the string points to time function. And then we can concatenate. And what we're going to do is just put the time that our class starts and the time that our class ends. Okay. And the way that we want to do that, though, is we want to use, let's think about today, for example. So the year first, 2021. And notice that I used 4 characters there. I gave the 2000 year part. All right. This was important when we had the turn of the century from the 1999 to 2000, but certainly as you're moving through history, if you're just studying long time scales, it's important to denote year using 4 characters. Okay. So then we can do the month after that, and we're in February now. So notice that instead of just 2, I put 02. So we're doing the same thing as we did with year. We're standardizing the number of spaces that are used for that. In most of our years, January through September could be shown as a single digit, but then as you move into October, the 10th month, November, the 11th, and so on. Okay, so so 2 for that, and then the same thing for the day. So today is the 9th, so we'll put 09. Okay, and then let me just show you the kind of format that we're going to be using here. So it's year, month, day. Then we can do hour, minutes, and seconds. Okay, and so that's what and it ends up being a long string of numbers, but we're going to format this in a way that it makes sense. Okay, so our class starts at 11. The 11th hour, 30 minutes, and we'll say 0 seconds. We'll pretend like we're actually perfectly on time. And by the way, there's a class that's in this room before me, and sometimes they go long. And so if I'm just a couple minutes late, that's typically why, because you just got to transition between the 2 classes. Okay, and then what I want you to notice here. So let's start to enter the time that our class ends. Okay, and we'll pretend that we're ending on time. And so we'll say 2021, 02, 09, and we end at the 12th hour and 45 minutes. Is that right? Okay, and then we'll say 0 seconds. But what I want you to notice is that there's now a bar here where I can move back and forth because the string of code went so far, it's larger than the window that we currently have in this upper left. And there's a couple things you can do. One is you can drag the other windows and make them smaller, or what I like to do is just after this comma, hit enter. And notice when I did that, there's now a justification where the second time interval that we entered is perfectly even with the first one. And that's because RStudio recognizes that comma was there, and it's expecting an argument that's at the same level as the previous argument. Okay, and the added benefit to doing this is now we can just on the fly notice that the number of characters involved with both of those are the same length. And we're dealing with these long vectors like this. It can become cumbersome. One thing you could do is just drop the seconds, and I'm going to show you the formatting argument next to specify to the string points to time, you know, what each of those represents. But the added benefit of doing that is now we don't have to scroll left and right in our window, and we can just quickly check to make sure those are on the same length. Okay. So then the last argument, and so notice we have the STP time, open parentheses, then we have C open parentheses, and we close the C parentheses here. But if we want to add an argument to the STRP time, an additional argument, we put the comma there in between those 2 parentheses. Okay, and then we can hit enter, and notice now that it's lined up with the start of the function. So it's expecting to see an argument that is nested within the STRP time. Okay, so how far that offset is actually pretty informative for how R is interpreting the arguments within the function that you're creating. Okay, and the last little bit that we're going to give here is we're just going to tell it the format. And here we'll put this in quotation. So we're going to use the %, and then a capital Y, which means that the first, so the % is it's going to look in that string of numbers, And capital Y means it's going to take the first 4 and assign that to year, okay? Then we're going to keep looking within that vector of numbers, and we're going to grab month in lowercase m. So it's going to grab 2 of the characters and assign those to month. Then we're going to keep going, and we're going to assign the next 2 to day, lowercase d. Okay, then we're going to keep going, and we're going to grab hours, capital H. And then we're going to keep going. We're going to grab M, and it's going to automatically grab 2 of those characters for the minutes. And then the very last, as we continue through that vector of numbers, we'll grab seconds denoted as a capital S, okay? So this is the kind of first indication of what a headache time is, because you kind of got to know you kind of have to commit to memory some of this case sensitivity in the formatting there. But as you work through your own data, you're going to be intimately aware of the formatting. And so, once you format it, it'll be in a consistent format, okay? So now we should be able to hit run on this. And notice that it pushed it into the console. And every time we went to the next line, so here we had that comma and we hit enter. Notice that you get a plus sign over here on the left side. And what that means is that's a continuation of code from the previous line. And then there's a plus line there, or a plus sign there. We're continuing the code. Then we end the code and we go to the next line, and notice now we have this right-facing arrow. And what that indicates is R is ready for the next line of code, okay? And it created an object called class under time in our environment here. And it's giving us this denoting the position within that vector of data that we gave, and it's telling us the format. And so I can click on this thing, and so notice that we can, that it's telling us it's created a list essentially, okay? So the first object in the list and the second object in the list, okay? And then we can also view it over here by selecting this down arrow, and then you can see the format, and it's telling us. So the year 2021, the second month, the 9th day, 11:30 a.m. and 0 seconds. Okay, so it's interpreted that as in the way that we wanted it to. Okay. Following this kind of general convention. Okay, so time, as I said, is the one that probably gives folks the most trouble. If you're doing time series analysis, you want to really pay attention to that. If you're not doing time series analyses, if you're doing, broader scale data where you only maybe need a sampling year, it's much easier to assign that to a year. Okay. So that's all I've got for you to finish up the stuff from Torps and Bauer. You can, of course, read that very brief introduction to R if you want a little bit more detail than what we went through, but we hit most of the high points. And that's, the whole idea is to just give you a kind of a nice foundation to start on with some of the basics of entering code and interacting with RStudio. Okay. The thing I didn't show you is how to save this. And by the way, so you can just go to File, Save As, and you can choose a place. I'll just save this in Documents, and I might call this, coding example from February 9th. And I can hit save, and notice that the name of that object appears up there, okay? And so if I close this down and I want to come back to it, I can open it up, and let me just do that. Oh, the other thing is, do you want to save the workspace image? So it's asking, do you want to save an image of your console? And one of the nice things about using RStudio is all of the input code is saved. We don't really have to save the output. We can easily create it again. So I typically don't save that. So I'm going to say don't save. Okay. And then if I can find my way to Documents on this computer, here we go. Coding example February 9th. So I can double click on that. I'm going to open that with RStudio. And this computer is a little pokey today. But what I want you to notice, what comes up is here is the code that I typed, but now the console is empty. It's showing the general information that you get every time you open it, but none of the code that I had put in there earlier is there. Our environment is empty, and it's still on the help window from the last thing that we looked at with the internal help, okay? And so the idea is now you can run all of that again and create that output if you're but you know, you could modify things as you need it, okay? And that's the nice thing about using RStudio is you can save those R scripts and open them again, and you can share that script with others that are using RStudio, and you should be able to create a replicated example, okay? Any questions or discussion for the kind of wrap up of Torps and Bauer? Okay, cool. Well, I'll just stop the recording for a minute.